Hi, today we will talk about BAENOTE, the final project of Erik, Brian, and me. The project is Notepad with undo and redo options, and you can save file, open files, and is entirely in GUI. We choose to do the notepad because first of all is indispensable. Notepad is an indispensable part of our life. We actually use it every day. And in the notepad we implement the undo and redo that because we always use also undo and redo, and we implement the data structure to do the undo and redo. We use the stack and the linked list, and well, the data structure is data organization, management, and storage format that enable efficient access and modification. The methodology is divided in 7 parts, and the first one is Java Swing, which is it is a part of the JFC for creating Windows-based applications, so the GUI. The second one is the menu. We choose with the menu you can choose from multiple options in a space-saving manner. Then the third one is a scroll bar, that is a scroll panel that provides a scrollable view of a component. Then there is the file chooser, the fourth one, that open files, select multiple files, and open the saving dialog box. The fifth one is the stack. The stack are basic data structures in which items are added and removed at the top. Then there is the linked list, the sixth one. The nodes represent, record, and store data, and their pointer links them to the next node. Then there is the key event, the last one, that is used to detect key processes on a keyboard, mainly by detecting keystrokes.
So first is Java Swing. Java Swing is a package to provide classes that for the Java Swing API, such as JButton and JText fields and JText area, and the JMenu and the JColor chooser. And first is JMenu. JMenu provides the options that you can choose. Like for this case, we use open and save to open the txt file and save the txt file. Let's move to the code part. So in the code part is we use file name intention folder to set the folder into txts that you can fastly choose the txt files. And next is we use select file to determine your file's location. And we use string full path to get the absolute path. And we use file reader to read the strings in your txt files and put the strings into the JText area that will be shown in your screen like this. Okay, so we choose stack and type something. We save it. We save it like we save it as a txt files, and we open and we clear the JText area and we open the txt file. Okay, as you can see, there's name happy txt, and The files of the type, as I said, already used the folder to set the folder as the txt file, so you can easily to find txt files. So you open it, yeah, and back to the slide. Uh, the next is the score bar, because sometimes user will um, put a lot of strings in text, and you need to have the score bar to uh, that user can score down and find their text. Yeah, like this. This is the uh, code of the score bar. We use score pane contents vertical score bar always to attach the JText area with the score bar. That the score bar can uh, detect the text in the text area and decide to score down or score left or right. So next is stack, and how does the stack work? Uh, there are main two operations we use is undo and redo. So first, when you type in a strings and you press the space button, it will save the text into the push into the stack, and we need to like undo, and you need to the pop the text in the stack. I can show you in the code part. So first we type this. As you can see, when I press the space button, it will state the stack, push into stack. And when I press Control plus Z, it will back, as well as the time comparisons. We already calculate the time. So as you can see, we use space to push the text into the stacks, and when you press like Control plus Z, you uh, pop the strings inside the class, inside the stack. So next is about the linked list. So as you know, linked list is a common data structure which using node as means to represent a record and store data using the pointer in each node to link to the next node. Unlike stack is the uh, default. As last in, first out is really suitable for the undo and redo. So how do we use linked-based implement in our final project? Okay, this is the code part. We create two linked lists. One is for undo and the one is for redo. So when you press the space button, it will add the element into the undo, and when you press the you press the button enter, you will add the element into undo linked list, and when you press Control plus Z, you will create the temp, and you will save the last element into the temp, and remove the last element, and add the element in the temp into the redo linked list, and set the text in our text area. And when you press Control plus Y, um, it'll create the temp file and get the last element in the redo linked list, and remove the last element into the redo, and add a element in the temp into undo linked list, and set the text on our text field. So next is the final one, is the key event. We need to let user to be easier to use this program, so we design like free to detect the user input. So when you press the space button, it will push the text into the stack or add into the linked list. when we press Control plus Z, it will execute the undo step, and when we press Control plus Y, it will do the redo step. So, key event can use to detect the key press on keyboard. The key category mainly deals with the events related to keyboard keystrokes. So first of all, we use key press to detect uh, whether you have pressed the keyboard or not, and we use get by key code equals to key event space. To that equals when it equals to space, it will do the save, and when we press the Control plus Z, we use this code. We use multiple detections. We detect when you press Z and when you press Control. It will uh, execute the undo, and when we press the Control plus Y, it will execute the redo. So that is the mainly code part in our final project. And next is about the performance and the time-space complexities.
So the theoretical part of this code, I'm going to talk about the time complexity comparison first, because in our code we made the stack version and the linked list version. So there are 4 parts in the time complexity comparison part. And in the first part, I'm going to talk about theory and the pseudocode. And the second part, I'm going to use graphics to prove my pseudocode and the theory. And the third part, we design an experiment. And the fourth part, we are going to see the result of experiment and discuss the conclusions. So here the first part starts. Okay, so the first part, theoretical and pseudocode. So first of all, we make the stack version of it, and the saving method of the stack, we use push. So only pushing data into a stack, the time complexity is only O of 1. And as for the undo method, because there are a few steps, so the first step is we pop the data in undo, and then we save it as temp, and then we push the temp into redo, and then the last one is to set text. Let temp become a text of the text field. So basically, these 3 steps are all O of 1. So the total will become O1 plus 1 plus 1 equals O3, which is also viewed as O1 because it's just a constant, not linear nor others. And as for the redo method, it's just basically the same as the undo method, but we change the redo into undo and undo into redo. So the total is still O3. Okay, so next I'm going to talk about the linked list save method. Linked list save, we use undo.add, which we add the data into a linked list. So this is like, we can tell from itself. So the time complexity is going to be O of 1. And as for linked list undo method, there are 4 steps. First of all, like we did in stack undo, linked list undo, we save the undo into temp, and then we add the data into redo, and then we remove the last data of undo, and then we set the text field to temp. So to get the last element of the linked list, we need to get through n data. So the time complexity is going to be On, and redo and add 1 data into a linked list is like pretty straightforward. So it's O of 1. And then as for remove last, we need to go through n data in the front. So the time complexity is also going to be On. And set text, we just set the text of the text field, so it's going to be O1. So the total is going to be On plus n plus 1 plus 1, which will be considered as 2n plus 2, and it's On, so it's kind of linear. And for the redo method, it's basically just same as undo, but we change the redo to undo, undo to redo. Yeah, so the time complexity of the linked list redo method is also O2n plus 2. So I'm going to the next part, graphic part. So the saving method are all the same in both ways of storing data. Basically, there are no difference in the graph because they're all of one, and we can see from the picture, like here. So both of the time complexity of the saving method is O of 1, which is a constant that O equals 1. So it's just basically this line. Okay, so that's not a big problem. So next image. Next, I'm going to talk about the saving, the undo and redo project. So we can see from the pseudocode above, basically the undo and redo method are similar, and according to the time complexity we estimated, we can assume that the graphic should look like this. So there's going to be two lines. The stack is the blue line, and the red line is for linked list. Linked list stands for O2n plus 2. So we set O as Y and then N as X. So we get this linear graph. And the stack is the constant, which is O1 plus 1 plus 1 is On. And so we set O to Y and Y equals 3. This stands for the stack. And this is the time complexity of a stack. And so about the meaning of this image, we can see that to some amounts of data stored, data to undo and redoing, linked list is going to be faster than the stack. But after some amount of data have been stored, the time complexity of the linked list will be huger than stacks. So we can observe from that chart, this chart, while dealing with similar amount of data using linked list method will be slightly faster. Yeah, I just mentioned that. And if it's like have a larger number to redo and undo, or if you are entering a longer sentence, the linked list will be much slower than stack. So next part. Since the theory part, we assume that there's that when dealing with some small amount of data, the linked list method is going to be faster than when we're dealing with the stack. But so here we made an experiment. It have to be separated into two parts. So we designed an experiment that we enter small amount of data. We will enter hello world and observe the runtime of undoing and redoing. And the second part is we will enter just some random sentence. But the sentence in every test will be the same. Just some random sentence to test about the runtime. So here are some results. So the small amount of data, we can see there's the stack right here, and we take, actually in here there's 5 experimental results, but actually we take more than 5, and then we delete the 5% in front and 5% at last, so we can get the how to say that, so we can get more closer to what it actually is. So here are the average undo and every undo of the stack and average redo of the stack, and also we show other average of linked list, and in a large amount of data there's average as well. So by this chart we can see by that chart, when dealing the large amount of data, the linked list is going to take nearly 1.5 to twice as more time than the shorter sentence experiment. Okay, so that's the time complexity part. Now I'm going to talk about the space complexity. So in space complexity part, I'm going to separate into three parts. First part, I'm going to talk about general, and second, I'm going to talk about stack, and third, I'm going to talk about linked list. So here I'm going to talk about general. When we store n items, n data store n times. When it's, then the space complexity is going to be O(n) because we store n times. However, storing an item once, n data store one times. Like if you just for example, like copy paste, you just paste something and then just save once. Then that's a lot of things be stored in one space. So the time complexity of that will reduce to O(1). So in our piece of code, we store the data whenever the user hits space key. So if we type a sentence, word by word, space by space, for example, in hello world, there's going to be one space in between, and after we end it, it's going to save it again. So the space complexity will be 2 because we store 2 times. Okay, so this is the general part, and next I'm going to talk stacks. So the space complexity of stack.push and stack.pop is O(1). Is combined. So combine the concept with the storing way we mentioned in general. The space complexity is shown here. So when we store n times, it's the time complexity. The space complexity is going to be O(n). And if we store 1 time, like we paste it, the space complexity is going to be O(1). The next part is linked list. Linked list, because the property of linked list holds 2 main prices of information at one slot. For a piece of data, it's going to hold 2 informations. So this means that the amount of data stored increase linear with the number of nodes it is list. Therefore, the space complexity of the linked list is linear, is O(n). So combine the fact of saving data, which we mentioned in general, the time complexity is shown below. So the store, if it's stored n times, and it's going to be O(n) squared. And if we're pasting something onto it, so it's going to be O of n times O of 1 is going to be O(n). So let's go to the last part. I'm going to talk about the results and findings and also some conclusions. So in the comparison part of the runtime, although the data we test might be not enough for big data, but what we did is remove the smallest 5% and the largest 5% in order to reach the normal distribution. And the result matches the theory more than the data that is not being removed, which it makes sense, since the more experimental data we get, the more data is close to the average, which is definition of the normal distribution. And that is why we remove the first 5% and the last 5%.
This is my feedback video, and this semester I think that we learn many useful things like stack and linked list. I think are the one that will be more useful for me in the future. I think because I can implement them in many things, and I like the how we structure the course with more team projects, with more presentations. So we need to do more research by ourselves. I never really wrote a report, so for me it was also interesting and challenging write more those reports. So I really like this course, to say. I know I could do better, I know, but Yeah, it was really good, well structured. I like the book. The book is really nice with all the codes. Is really well done. Yeah. Bye bye.
Hi, hello, my name is Brian. And in this course, I learned how to make my own program more efficient by studying the time and space complexities, as well as the sorting algorithm. We compare like Reddit sort and insertion sort to know their time and space complexities and know their algorithm stack and pseudocode. And in this final project, we learn how to implement the data structure into our own applications to make more efficiency by measuring their running time. This semester have less homework than the last semester, which allows me to have more time to study Java and become more proficient. I think this class allows me to learn more about the theory behind the data structure.
Now I'm going to talk about the feedbacks of this semester. I think data structure class in this semester, I've learned a lot of things. I think it is very useful for example, I learned stacks and linked lists, and we learn how it works because in Java there's no pointer, so we code ourselves some pointers, but we call it node right here, and I think that's pretty useful for my computer science course. So I think it helped a lot, and the book I buy from the professor has a lot of views, and there's a lot of code inside of it that I have learned. And also the exercise. Every exercise is pretty meaningful for me because I spend a lot of time doing it, and we did hand in some projects, and it also built my confidence. I think it's pretty useful, this class. I think, yeah, it will help me a lot when I go to America, and I really like it. Thank you for listening.